So if we look to work this out, what we'll see is, once again, we need to work out how many pixels across. So we can multiply the number of lines by the pixel ratio. So we know we get 2048 pixels across. And therefore, by multiplying these two together, we'll work out, we get about 2.35 million pixels that make up an entire screen. So now we're going to have 50 full screens worth of pixels to be sent every second. So if we times that by 50, we end up about 118 million pixels per second being transmitted to make up our full picture. So now that's a big jump from about a factor of 10 jump from our previous. So we're now down to about 8.5 nanoseconds for each pixel to be transmitted. And once again, we can work out our fundamental frequency. Again, one cycle of a sinusoid could possibly send 2 pixels. And so we've got 1 over 2t to give us our fundamental frequency. And we're looking at about 59 megahertz of bandwidth to send our signal if we sent it in that form. So that tells us a little bit about how we work out a rough estimate of the bandwidth. Of course, that assumes that we're only sending the fundamental frequencies. Often we want to shape our pulses a bit more than just sinusoids, and then we might need some more bandwidth to do that. But we'll look at that when we look at signals in more detail in the session after Christmas. So the last thing I just want to mention is sometimes we want to then send these messages over the air. And this is where something important comes about how we move our bandwidth. Our bandwidth changes as we move through our system. So often we take those signals, and those, as we saw in the diagram, those signals are generally at baseband, so they'll occur from 0, and we're going to modulate. We're going to put them on a carrier. And so what that's actually going to mean is that we shift those signals so they're no longer at 0, they're now centered at some frequency f. And so we'll go from something where we define our bandwidth in one way, on a single-sided, to now actually them being double-sided. And the process of modulation itself may also change the frequency components that are in our signal. So as we change our signal to modulate it, whether it's transmitting it over the air or through optical fibers or sometimes on cables, we're going to change the way our signal actually sits. And all of our wireless systems do this. They will set these signals on particular carriers. So these are just an example of some of the carrier frequencies that we use to transmit our signals. And as I say, even cables sometimes do this. So the ADSL, the broadband that brings cables to your home, has translated some of the data that is sent onto different frequency bands. So what you have is, down at the lowest frequencies, we have the telephony system, plain old telephony, POTS. Whereas your data, the data that you're receiving, is in a frequency band here, and the data you're transmitting is in a frequency band here, and the data you're receiving is in a frequency band above it. Whereas when they started out, all of these will have been baseband signals, but 2 of them are translated up to higher frequencies so that they can be transmitted at the same time. And so this is called a frequency division multiplex or a frequency division duplex. We use duplex because they're going in different directions. So over these 3 sessions, we've looked at how we represent a sinusoid and combinations of sinusoids, because they're really our building blocks for how we describe our signals. And now we should be able to do that in the time domain and in the frequency domain using both one-sided and two-sided spectra, and mathematically express those using the complex exponential form. And we've also looked at how we define our signal types. We've looked at how we calculate our bandwidth and how we use Fourier to do that, and how we might need to use modulation to translate some of our signals. So in the session after Christmas, we'll return to digital signals and look at how we transport them. So thank you. Thank you all for sticking with these videos and for getting to the end. I'm sorry we've had to change the classes around a bit, but hopefully you found the way these videos have been done very useful. I'll see you all in the revision sessions if you've got any questions, but please also post questions to the forum. So you should have quite a lot of material now and a lot of things to go back and revise. I'll try and do some of these videos for some of the bits from the middle lecture that I was there for, and hopefully they will help you as you revise. And well, I'll see you for the revisions lectures, but if I don't see you, have a good Christmas.